Hello and Assalamualaikum warahmatullahi wabarakatuh. Today I will present about our control system project. The project title is Transfer Function and Bob Plot in Electrical System. Our group members, firstly, my name is Muhammad Azizhan bin Hanafi. And others group members is Zurizlan bin Mutalif and Muhammad Khairul Ikhwan bin Hamdan. Our lecturer is T.S. Muhammad Fauzi bin Zakaria. Now I will pass to the Muhammad Khairul Ikhwan to his part. Thank you.
Connected in series or in parallel. The name of the circuit is derived from the letters I used to denote the constituent component of the circuit, where the sequence of the components may vary from RLC circuit. Second, what is transfer function? Transfer function for components are used to design and analyze system assembled from components, particularly using the block diagram technique in electronic and control theory. And third, what is Bode plot? Bode plot is a graph of the frequency response of a system. It is usually a combination of both magnitude plot, expressing the magnitude usually in decibel, of the frequency response, and a both phase plot, expressing the phase shift. Next, what are the applications of resonance RLC circuit? RLC circuit have many applications as oscillator circuits. Radio receiver and television set use them for tuning to select a narrow frequency range from ambient radio wave. In the role, the circuit is often referred to as a tune circuit. An RLC circuit can be used as a band pass filter, band stop filter, low pass filter, or high pass filter. The tuning application, for instance, is an example of band pass filtering.
Okay, I will present about how to get transfer function from the circuit. We have 5 procedure. Firstly is draw the given electrical network in the S domain with its inductance L replaced by SL and its capacitance replaced by 1 over SC. After that, replace all source and time variable with their Laplace transform so that Vt is replaced by Vs and It by Is respectively. Thirdly, use KVL and KCL, mesh analysis and also node analysis to write the network equation. After that, solve the equation simultaneously for getting the output. And lastly, form the transfer function. Okay, after we get the transfer function from the circuit, now we can do the Bode plot into the semi-log paper. To do the Bode plot in semi-log paper, we need to do calculation first. Based on the transfer function that we get, GS equal 10 over S over 10 plus 1. We need change GS to frequency domain. After that, we need calculate the constant gain. Constant K is 10. We plot in 20 log K, so we plot 10 and we get 20 dB. After that, we calculate the simple pole. While simple pole P1 is 10, we divide P1 by 10 and get 1. And we multiply P1 by 10, so we get 100. Now we can plot in semi-log paper. First we plot the magnitude. After that, we plot the phase. That's all. I will pass to my friend. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zul Izlan bin Muhalif, and now I will continue to explain about the presentation for this project. And now we go to the board plot in MATLAB. So for this case, we should put the right coding to find the board plot. So first we put the transfer function, which is gs equal to 10 over 0.1 second plus 1. And then we put the numerator, which is 10. And then the denominator is 0.1 second plus 1. And then the transfer function is g equal to tf in bracket numerator comma denominator. And then we put the plot frequency response, which is bot in bracket g comma grid. After that we run the coding in MATLAB and get the final result for board plot, as you can see at the screen now. And then we find the gain margin and phase margin. As you can see, as at the left side is coding for margin, and at the right side is the result for coding for margin. And then we go to the comparing result. So compare result from by hand using Semilog paper and by MATLAB. So from the result that we get in MATLAB, we verify that the results corresponds to by hand sketch with asymptotic plot. And then for common on stability, which is margin, based on board plot in MATLAB, the gain margin and phase margin that we get is first, for gain margin is equal to infinity, and then for phase margin is equal to 95.7 degree, which is at 99.5 radian per second. While gain margin and phase margin are positive, we assume the system is stable system. And lastly, for the conclusion, the transfer function was the primary tool used in classical control engineering. However, it has proven to be unwieldy for the analysis of multiple input, multiple outputs, which is MIMO systems, and has been largely supplanted by state space representations for such system. In spite of this, a transfer metric can be always obtained for any linear system. Other than that, for this project, it's easy to make board plot using a MATLAB software. But to extract salient features from a board plot, so as to help circuit design, it is more useful to factor the transfer function into simple zero pole form. I think that's all from me. Thank you.